My name is Innocent Chikopa, the Dean of Faculty of Science. I will take you through regression. And in regression, we would like to explain what regression is and why it is used. We're also going to calculate and interpret the values of the intercept, y-intercept, as well as the slope of the least squares regression line. We would like to use the relationship between the two variables to be in a position to predict the values of one variable given the other variable. We are also going to do the linear interpolation, that is fitting a straight line through the data points and be in a position to use that particular line to come up with an equation as well as the values that are needed in the given data set. So that's interpolation, but at the same time we'll try as much as possible to look also at the extrapolation. Basically, all of us most of the times know that some measurements are related to one another, and when we're talking about a relationship, there are different types of relationships. So some of the values that we can think of is the height, let's say, of a child and the age of the child. We all know that when the height of a child is increasing, we're also thinking that the age of the child is also increasing. In other words, when the child gets older, we are also expecting that the height of that particular child should also be growing. This implies that the height of a child increases as the child becomes older. Regression is a statistical procedure that determines a relationship between one set of variables or measurement and another. The type of analysis that is going to be covered, like in this particular lesson that we want, is actually looking at how we can fit a line in order to analyze this particular relationship by using what we call the regression line as well as the regression equation. Basically, as we have already said, regression is just one way of analyzing the data, coming up with a relationship within variables. It's not the only one. There are several other methods that we use. For example, we may be looking at a correlation later on, but for now, we're going to look at regression only. So, we will start by looking at linear regression. We'll start by looking at linear regression. When I talk about linear regression, we are talking about a line. We are going to talk about, we are talking about a statistical technique used to compute the best fitting straight line through the data set. And that's what we call the linear regression. So in other words, we are looking at a linear relationship which can exist between two variables. It could be more variables, one or two more variables, but in this particular case, we're only looking at two variables, which we will call y variable and the x variable. The y variable, we're going to call it the dependent variable, and the x variable, we're going to call it the independent variable. We can illustrate the regression by coming up with a graph in which we can show the relationship between these two variables in terms of the linear regression. For example, I may have that particular graph. So we all know that this is the x-axis and this is the y-axis. So let's assume that so up to 40, we can assume that these are values of x, and then the values of y, we could go, let's say this is 20, 40, 60, then 80. So if, for example, we have a scatter diagram, and then we have a line that goes straight these particular points to show that when x is increasing, y is also increasing. This is what we call regression line, which has actually been fitted. We can plot it to show the relation between the variables x and y. But oftentimes we have used to come up with this particular, we have been used to come up with this particular line, but just by using the I, just to say this particular line should actually be fitting in this particular data set, by making sure that half of the data points are below the line and half of the data points are above the line. This is just using the I, and sometimes some other people call this one drawing the line by the I, drawing the line by the I. But there is a very good mathematical method in which we use to fit this particular line. And this particular mathematical method, we call it the method of least squares. Method of least squares. The method of least squares. That's the one that we use. It's a mathematical method which can actually be used to fit in the straight line. So this best fitting line, because we are saying some people think of this particular line just by considering, as I said already, the half of the data points should be below the line and half of the data points should be above the line, and is fitting this particular line by the I. However, in mathematics and statistics, we have a mathematical way of fitting this particular line, which we are saying is the method of least squares. The method of least squares, we fit in the line, and this particular line is actually going also to be called the least squares regression line. Least squares regression line. It's the line that you fit using the method of least squares. The method of least squares is actually calculated by calculating or by getting the least squares regression equation. So for us, by getting the least squares regression equation. So we are saying, mathematically, we can use the method of least squares to come up with the least squares regression line. And the relationship of variables can actually be determined by using the least squares regression equation. The least squares regression equation. And this particular least squares regression can actually be represented graphically by the least squares regression line. So the least squares regression line is used to represent or to present the least squares regression equation in the data set graphically. So, why do we need to do this? By calculating the least squares regression equation of any other line, we can be in a position to model the linear relationship. To model the linear relationship between two variables. So when we determine the least squares regression equation, we can actually model the least squares regression in nature. In other words, model the linear relationship between two variables, but at the same time, be in a position to predict. So the linear regression equation is used for prediction. So to predict the values of one variable, given the other. So given the other. So these are the two important things that we use the linear regression equation for. So determining the model of the linear relationship, but at the same time being a person to predict the values of one variable given the values of the other. Now, how do we come up with how do you come up with the least squares regression line? The least squares regression line. This is a line that minimizes. So this is a line that minimizes the sum of the squared vertical distances. So the line that minimizes the sum of the squared So that minimizes the sum of the squared distances of the points from the regression line. Distance of the points from the line. So that particular line that is going to minimize this is what we call the least squares regression line. What we are trying to say in this particular case is that let's go back to look at the graphical presentation that we had just by looking at this. If we consider this particular graph, so we have the y-axis and we have the x-axis. What we're trying to say is that if you come up with the data points on your graph, and then you fit in the line. We fit in the line. Let's have that particular line, a straight line. They're describing a straight line describing the relationship between these two variables. There could be several lines. Let's say this is the line number 1, and we consider this other line as line number 2. We can also have another line. Let's assume that we have this particular line. And probably, let's have this other line. Let's have this particular other line. So you see, I have 4 lines. These particular 4 lines, when you look at them, all of them are showing an increase in y given x. So you can see that all of them are describing the relationship between these two variables. So we have line number 1, line number 2, line number 3, line number 4. Now we would like to say, if I take this particular point, and go up there to this particular line, which is line number 4, this particular distance is the deviation of this particular point from the line. Now, if I go to each and every line, I will have the different distances. So if I take all the other points and then I square the distances from that particular point to the line, that is what we call the squared distance from the point to that particular line. So the line that is going to give us that minimum, the minimum squared distances, that one is what we are going to call it the least squares regression line. So among the 4, which one is the best line? Which one is the line that is going to bring the minimum, these particular distances that we are talking about, the squares of these particular distances to minimum as much as possible, almost 0. That one is what we are going to call the least squares regression line. This one, it means that if you were collecting data without errors, then that's what could have happened without the errors. But this particular error is coming in because of some other problems that we meet when we are collecting data. So from this particular point to that particular point, or from this particular point to that particular point, if I'm considering the blue line, if I'm considering the black line, then I'm talking of this distance. If I square it, then I go to this other point, this distance, this particular distance. If I square them and then add, they will give me a certain sum. That particular sum, for all these particular lines, which one is going to bring the minimum value, then that particular line is going to be called the least squares regression line. Then, apart from the least squares regression line, we are saying that this particular least squares regression line can actually, so we are saying from the least squares regression line, we can come up with an equation which at the end of the day can be used to describe that particular relationship, and then at the end of the day use it to predict for the values that may not be in the given data set. So those particular values, when we're doing that, we'll be talking about interpolation and extrapolation. Take note that the least squares regression line is actually used to describe the relationship between two variables, but at the same time be used to predict for the unknown values of y given the values of x. So we should be in a position to do that.